So we're looking at the function f of x equals x cubed minus 9x squared plus 24x minus 2 on the closed interval from 0 to 5. What we're going to be doing is finding the absolute and local extrema of this function. On the closed interval, that is. So we have to find the critical points. Critical points include the endpoints, so we already know that it includes 0 and 5. But to find the critical points, we have to know where f of x, or rather f prime of x, either equals 0 or it does not exist. So we know that f prime of x, also known as the first derivative of the function, would be 3x squared minus 18x plus 24. Now, this is a quadratic. In fact, it's polynomial, so we know that it's existing all the time, including on our closed interval 0 to 5. So we have to find where f prime of x is going to equal 0. So 0 equals 3x squared minus 18x plus 24. Break that up into its components, which is going to come out to 3x minus 6 times x minus 4. Now this will give us x values of x equals 2 and x equals positive 4. So we have a positive 2 and a positive 4 are going to be where f prime of x is equal to 0. And where the slope is equal to 0 is going to be either a maximum, a minimum, or possibly just a excuse me, a transition point in terms of going from slope down or curve down to curve up. So knowing this, we will plug in now our x values into the original function since we have our critical points, knowing that the quadratic exists on all reals. So we have f of 0 equals f of 2 equals f of 4 equals and f of 5 equals. So f of 0, well, we plug this into the original function, x cubed minus 9x squared, blah, 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 is going to come out to negative 2. F of 2 is going to come out to, well, 2 cubed is 8, minus 9 times 2 squared, so that's going to be 8 minus 36, and then plus 24 times 2 is going to come out to 48. 48 minus 2, okay, so math's coming out to 18. 18 if I'm not mistaken. And then we have 4 cubed minus 9 times 4 squared. So we have, 4 times 4 is 16. 16 times 4 is more. Blah, blah, blah. Doing the math over here with my other hand. And it's coming out to 14. F of 4 is equal to 14. And f of 5. Well, that's going to come out to 5 cubed is going to be 125 minus 5 times 9 is 225, I believe. And then plus 120 minus 2 is going to come out to 18. Alright, so we're going to look for our absolute smallest value here, which is looking like f of 0, because that equals a negative number, and no other numbers are negative. So this will be our absolute and local min. And then we have two values here that are the largest at f of 5 and f of 2. Now, the actual wording was find the absolute, or find the local and absolute extreme values of the function on the closed interval. So it just wants the largest values and smallest values. So that would be 18. If it were asking for the points at which it came, we would say at 2 and 5 on the closed interval. But for now, if I'm interpreting this correctly, it would say that these 18s would be the absolute and local maxes of the function on closed interval. Make a little addendum there. Now, just to verify that these are the points that we think they are, which sounds weird, but it's what we're going to do, we're going to pump out a quick little sign chart with the f prime function with its components. So we have 3x minus 6 and we have x minus 4. And we'll put this across. We're going to include our critical points. So we'll have 0, we'll have 2, we'll have 4, and we'll have 5. Alright, and this is a closed interval, so we don't care about anything before 0, and we don't care about anything after 5. Everybody with me here? Waiting for this camera to focus in. Okay. Everything makes sense so far. And we're just checking here. So pick a number between 0 and 2. Let's go with 1. 3 times 1 is 3. 3 minus 6 is going to come out to a negative number. 3 times 3 is 9. 9 minus 6 is going to be a positive number. And anything bigger than that is going to be positive. 1 minus 4 is going to be negative. 3 minus 4 is going to be negative. And something bigger than 4 minus 4 is going to come out to a positive number. So we know that the function is increasing on the interval from 4 to 5. We know it is decreasing because of a positive times a negative between 2 and 4. And then a negative times a negative means it's actually increasing on the interval 0 to 2. What does this mean? It means that we do indeed have a max because we can see the slope increasing and then decreasing at 2. And we can tell that we do have a possible local min actually at 4. So we may need to revise this. This is why we were checking. We see the slope was decreasing and then increasing. So it's decreasing on 2 to 4 and increasing on 4 to 5, which would actually give us a minimum value. Something important to consider. So this f of 0 would be the absolute minimum on the closed interval because it is negative 2 and that is the lowest value. So we're just going to erase this because that's wrong. But that right here would actually be a local minimum. And that's why we check.